Okay, this is part two of the nomenclature video for ionic compounds. We had been talking about binary ionic compounds made up of two different elements, lithium fluoride, calcium bromide, etc. And we learned by looking at the periodic table in another video that we have to look at the charges that the ions get. And again, this is something you have to sit down and just learn. And you can use the periodic table for many of them. And some of them you have to go ahead and look at the anion to determine the charge on the metal. For example, something like cobalt 3 iodide, the reason you know that the cobalt has a +3 charge on it is because I have 3 iodides associated with it, and each iodide has a -1 charge. So once again, we can look over those as necessary. I want to move forward, though, with polyatomic ions. And I had mentioned yesterday about polyatomic ions in a video, and I want to continue that discussion today. Polyatomic ions, you don't have to worry about changing the name, for example, oxygen to oxide or fluorine to fluoride. The name is given to you when you look in the chart. You look at a chart of polyatomic ions, or once you've sat down and committed these to memory. So for example, if we look at CO3 with a -2 charge, the name of that is carbonate, and we don't have to change its name. So when it combines with a metal, CaCO3 would be just calcium carbonate. We don't have to worry about the name once we learn the name. Ammonium, as I said yesterday, was the only polyatomic cation that you need to know for this course. The other one is a mercury 1 cation, and we don't see it too often, but it is there in case you come across it on a chart. But this is the only one I would ask you to commit to memory, is ammonium NH4+. So we just use that as a standard cation, ammonium chloride, for example, in the first example is ammonium chloride, and you can combine the ammonium with another polyatomic ion. In this case, you'd have ammonium nitrate for that second example. There are 3 polyatomic ions that we want to learn that do end in IDE. Now, don't get these confused with fluoride, chloride, bromide, oxide, etc. These are the 3 polyatomic ions that end in IDE: cyanide, hydroxide, and peroxide. Peroxide is a form of oxygen that we'll be talking about, and it actually forms a polyatomic ion. Okay, yesterday I think it was, I posted a video about polyatomic ions, and we looked at a series of them containing chlorine and oxygen. For example, hypochlorite, chlorite, chlorate, and perchlorate. And I said in that video, it has to do with the number of oxygens that are attached to what we call the heteroatom, the atom that's not oxygen. In that case, it was chlorine. So if you were to go ahead and look at the chart, you would see hypochlorite, chlorite, chlorate, and perchlorate, and it all has to do with the number of oxygens. Hypochlorite was ClO with a minus charge, chlorite was ClO2 with a minus charge, chlorate ClO3 with a -1 charge, and then ClO4 with a -1 charge was perchlorate. So here we go. This is what I just said to you in a much nicer presentation. We have the various oxo anions, the fancy name for these things. And you could have these with chlorines, hypochlorite, chlorite, chlorate, and perchlorate. You could see this with bromine. You could see bromite, bromate, and perbromate, if that was a Br there. As a matter of fact, you could substitute any of the halogens for the chlorine there, and the nomenclature would be the same. Here's an example of another pair of polyatomic anions, SO3 with a -2 charge, sulfite. We add one more oxygen and we get sulfate. And these are the only two that you'll see. You're not going to see a hyposulfite or a sulfate, they don't exist. It's just these two. The same thing with nitrate and nitrite. That's another example. So if you go through here and name these chemical compounds, you may want to pause the video and give it a try. And if not, we can go through and name them right away. Now, copper is a transition metal, Cu, CO3. Carbonate is a polyatomic ion with a -2 charge. So this is copper 2 carbonate. That's the first chemical compound. Potassium sulfite is the next one, and potassium is not a transition metal, so we don't have to indicate its charge. It can only get a +1 charge. What do you think this one is? Well, what was ClO, right? This is your polyatomic ion. Remember, it was one of those oxoanions. And we have calcium hypochlorite. ClO4, that was the one with most oxygens. That was the perchlorate. Potassium perchlorate. Again, sodium chlorate, looking at our last slide or two. Lithium, this one is going to be lithium nitrite. NO2 with a -1 charge is nitrite. NO3 with a -1 charge is nitrate. And this is sodium acetate. And again, these are just things you have to sit down and learn. Unfortunately, there's no quick and easy way to do this other than to sit and study them and learn the names. But once you use them time and time again, you'll see it's quite straightforward. Okay, how to recognize ionic compounds. That's very important because next we're going to talk about covalent compounds and how to name them. So ionic compounds contain either a metal cation or ammonium as your cation. And if the first word or the first thing you see in that compound is a metal or ammonium, it's an ionic compound. Okay. Another thing to remember is that your charges all have to add up to 0. And that's why sometimes, like for example here in potassium sulfite, sulfite has a -2 charge, and I need 2 potassiums to balance that charge. And again, the charges come from the periodic table, or you can look at a list, or you can figure out the charge based upon the formula. And then parentheses must be used when there's when there are multiple units of a polyatomic ion. And I'll go through this quickly and then wrap it up. I try to keep the video certainly under 10 minutes. So calcium, for example, is always +2. It's in the group 2 on the periodic table. The ide in chloride tells you that it comes from chlorine, and chloride is always -1. Again, that comes from the periodic table. And if you didn't see the video on the periodic table, you can go ahead and watch that. And we would go ahead, we need 2 chlorides, 2 -1 charges to balance the +2 charge. So we're going to have calcium chloride. So it's pretty straightforward. Let's take a look at another one for iron 3 sulfate. Well, that 3 tells us that the charge on iron is +3. And sulfate is -2 charge. So we have the least common multiple is +6. So I'm going to need 2 irons and 3 sulfates to balance out the charges. And here's my chemical formula. The iron has a +3 charge, so I need 2 of them to make a +6. The sulfate has a -2 charge, so I'll need 3 of those to make a -6. So it's pretty straightforward. I'm going to go ahead and post this, and you can take a look at it today.